Hey everybody, today we're going to be talking about springs and a little bit how they act. So for what we did is we attached a spring to a surface and attached weight on the other end of the spring, ultimately expanding the spring. So using a dynamics lens and an energy lens, we're going to try to figure out how high we need to raise the spring in order for the weight to drop so that it barely touches the egg but does not crack the egg. Once we know the spring constant, we'll also know how far the spring will expand with a certain weight attached to it. With this, we are going to set our spring at an initial height, then raise the egg high enough so that the spring expands, but the weight doesn't touch the egg.
We began our problem by solving for the spring constant. We used a dynamics lens because forces cause acceleration. We first solved for the force of gravity in newtons. We did this by multiplying our mass in kilograms by the acceleration due to gravity, which is 10 meters per second squared. We have labeled the vertical axes on our graph with the force of gravity in newtons. After we attach our weight, we used a measuring stick to measure the change in height in meters with the corresponding weight. We have labeled the horizontal axes on our graph with the change in height in meters. We can now solve for the spring constant. Since the spring constant is defined as newtons per meter, our spring constant will be the slope of the line on our graph. Using the line of best fit feature on Excel, we calculated our spring constant to be approximately 10 newtons per meter.
So to find the height of the egg, we use the energy lens, and we said that energy is conserved, so change in energy initial is equal to change in energy final. When in the experiment, potential energy gravitational of the weight is equal to potential energy of potential energy of the spring plus kinetic energy plus potential energy gravitational, which ultimately at the end, when it's just on top of the egg, all the energy is converted to potential energy of the spring. So then we can take these two and set them equal to each other. So we have potential energy gravitational is equal to potential energy of the spring. And then when we expand this out, we have mgh, or delta h, is equal to 1/2 k delta x squared, where the change in h is equal to the change of x, of the displacement. So then we can solve for x. So ultimately it would be x, change in x will be equal to 2 times gravity, and gravity times mass over k. Because a kilogram is times m over s squared is equal to 1 Newton, then we can cancel them out. So our units work out.
Yeah, cancel.
So this is our change in x. So therefore, ultimately, our egg needs to be raised 34 centimeters or 0.034 meters in order for the weight to just hit the egg but not break it.
Now that we solved for the spring constant, and with the spring constant we solved for the height we needed to place the egg at, we can now actually start testing our experiment. For our test, we placed the egg on top of a notebook to make the distance from the ground to the top of the egg 3.4 centimeters.